Okay, so this is the session we're gonna have now is on the breakout session. So maybe I can just start and say, yeah, thank again the NSF and Phil and Shijay and all the other organizers and all the other participants. I think we had at least two goals in this workshop. One is to get to know what everybody else is doing. So I think that's very much been accomplished in seeing all the interactions. So that I think is, we now know what everybody's doing pretty much. And now maybe the second part here is sort of where the rubber hits the road or the pencil gets sharpened or whatever other metaphor you want to use, but sort of focusing now on, okay, now that we know what everybody's doing and we've had discussions around the HDR ecosystem, what are the things that now we should strive to do going forward so that we have actionable things coming out of this meeting and follow-ups and structure. So that's really here's where we come together with the breakouts. You'll see a QR code looming behind me here. If you either go to that short URL or the QR code, here's I believe this links to a Google Doc that everybody can add input to. So the way we want to do this, so sort of the artifact out of the session are the set of slides you'll hear from a leader from each of, I think, 5 breakout groups. In addition, the Google Doc that hopefully will capture the ideas and thinking around actionable items after this workshop is over, which is very close. And that will also be part of the output of this session and the whole workshop in general. So if you go to this Google Doc, please add any notes. You can also, hopefully we'll have time, we certainly have time to discuss the breakouts. So you'll have a chance to verbally add your input, but verbal kind of disappears into the wind if we don't capture it somehow. So it'd be great to put your good ideas, what we should be doing going forward, into the Google Doc that you can get at here. Okay, so one other procedural item is, so what we'll do right now is we will go through, there's a combined set of slides and that has there's a leader, one or more leaders for each breakout group. They will come up and give sort of a 5-minute summary of their slide or two. What we'd like to do is let them all go through their slides, and then we'll have all the discussion after we see the full set of slides. Otherwise, we'll have problems at the end with the last speakers having enough time. So let's let everybody go through the slides and discuss their findings and activities for the breakouts, and then we will have a robust discussion session on these items. And also, please capture things in the Google Doc that will. Are there any questions procedurally what we're about to do? Okay, I think not. So if you could, yeah, bring up the research, bring up the breakouts. I think the first one will be Phil, I guess, that you'll be talking. Okay, is your breakout just on research? That's a pretty broad.
Yeah, okay. So my breakout's on ML challenges. If you go to the next slide. Yeah, so this is the ML challenges, and these are all the people who attended the breakout. So thank you for attending. So if you go to the next slide, yeah, so the point of the ML challenges, just to give you an introduction, is that we have various different, all of us have kind of ML models. We have, a lot of us have a huge amount of data, very differing data, all sorts of different problems that we're looking at. And the hope is in the next year, we assemble the data in some scheme that hopefully all of us internally in HDR can process. And once we're comfortable, we try to release this data to the greater community. So beyond this, and in fact, we have, as part of our supplemental award, we actually have some money to host a workshop next year and well, let's say an award ceremony, and also what did we say? Hackathon? Not a hackathon. Not a what? Yeah, no. And so we'll host the challenge, but then we'll have the award ceremony, and we'll have like a kind of everybody will we'll have a group of people we can invite, and we'll have some kind of like a hackathon challenge at the workshop. So the idea would be in a year's time, we invite everybody to come to probably, I think we put UW, and have everybody come and we present the awards and so on. So then for the discussion session, we talked about various different problems that we'd like to do. And the idea here is, right, unlike the kind of, I mean, all of you probably know like the classic ML data sets, right? There's ImageNet. There's, if you want to do a little model, you do MNIST, right? If you like to do semantic segmentation, there's now Semantic Kitty, and there's like, there's a list of maybe 10 of these things that everybody uses. So the thought would be to make HDR themed ones that actually give kind of interesting problems. So here are two that we discussed last night. So the top one is from Xiao Wen from the iGuide. So the left here is it. So the idea here is you have all this public USGS data, satellite images, and so the left here is a river, and the purple is the first attempt at trying to find the river, and you can see it's not aligned. And then if you apply this deep learning model, so this is one from one of Xiao Wen's papers, then you get this nice river. And so the idea is you want to actually find the waterways. This is something, it's a nice ML problem. It's kind of a classic semantic segmentation problem, but it's very relevant to our everyday lives. And it's something that, we can certainly put in a challenge to see how well we can improve things. The bottom challenge is kind of a very interesting one in the sense that the idea here is that you have sensors, atmospheric sensors on various different power supplies, power lines. And then you also have atmospheric sensors not on power lines, just kind of in the ground. And the hope is you can use the atmospheric sensors to predict when there's going to be like a solar flare and you get a power outage. And so the idea here is to predict, the kind of probability you get a power outage. The interesting thing is that, sensors on power lines are proprietary. So this is not information that we could release public, but what we could do is make a reduced public data set that you can train your network on. And then we'll have to write some infrastructure to actually run the testing on the proprietary data to see if we can actually do this. So this is kind of a fun one in the sense that you get to actually test your algorithm on blind data that you never get to see. All right, so what needs to be done? Well, so we just talked about various things, but the idea was that we need some sort of framework for testing and validation. I think none of us at the table were familiar with these frameworks. There's things like, Hugging Face, or if modelshare.org. This is another way to kind of save models and save challenges. I wanted to advertise this here because I suspect there's somebody in the room who's like written their own ML challenge framework. And so if you have and you would like the HDR community to use it, please contact me. But the point being is we want to kind of establish, kind of challenges. If you look in the backup, we have the A3D3 challenges. We're actually about making very small models, but running them at very low latency, like below a microsecond, right? So, or actually generating glitch data, which is another challenge we're thinking about. And so the idea is that we have various metrics. We want to have these challenges, and we want to put together a scheme to actually organize this, release this, do this with the HDR community. So the idea is to start kind of a discussion for this and a timeline. So the thought is we want to get everybody interested. So please contact me if you're interested. We want to have a meeting before the end of the year. So I put before December. And the idea would then be to have an internal challenge to say sometime in June and release the official one in August. Naturally, these could slide, but we'd like to do this within the first year. So here's just an idea of a timeline, right? Here we are in DC. In 2023, we'll have, let's say, a monthly meeting to discuss the challenges, preparation of the data. Is it fair? Is it accessible? Do we have the infrastructure to run the testing? And then we'll launch an internal challenge, right? So all your students, your DSC, if you think they want to join the challenge, you can have them all join the challenge, right? The institutes, right? There's a broad range of people who would be interested with the challenge. If this works out well, right, we can take what we learn and say 1 to 2 months, or say 2 to 3 months later, we have a public launch. And then we have an award ceremony / boot camp is the word I was looking for. And so yeah, so that's basically the idea of the ML challenge. And so, yeah, just go to the last slide here. The real important thing is that, we can tie this to the greater community. We have Jeffrey Fox here. So tying this to ML Common Science, we could eventually take our winners of our challenge could eventually become scientific benchmarks, right? We could do latency. We can, there are many axes in ML Commons that we could think about. And, the other thing that that's even more important is that this is a way for us in the HDR community to interact with each other, talk about how we prepare our data sets, how do we, ensure our fair principles or, go across the community, and hopefully strengthen the community together. All right, thank you.
Okay, thanks, Phil. So next, I think we have, let's see, which is the, yeah, so Vandana and also Wes.
Thank you. Hi, everyone. I'm Vandana Janeja from iHarp and UMBC, and I'm going to have Bess talk a bit about too. But the first thing that I'll say is this topic of complex data kind of sits between the ML challenges and the inductive bias. It's really kind of crossing that line. And if you think about any big grand challenge type problem that you're trying to solve, you can look at it from multiple views. But when you want to bring in that multiple view related data, that's where the complex data problems happen. So maybe Wes can give a summary.
Yeah,
of what we discussed.
so basically, not as part of the DSC, but as part of other sponsored projects that I do, I'm running into this complex data problem a lot. So Vandana and I had a very robust conversation about this. So the example that we put on here was from the iHarp, since that's what we heard about this yesterday. So basically every complex system is going to have multiple views. And so, we called it maybe modal, multi-domain, multi-view. There's a lot of ways to say it. But for instance, you have like a piece of land that's like a physical, object. There are bounds on it. And you could look at the soil, you could look at snow sitting on top of it. You could look at the atmosphere above it, right? With all these different types of sensors, satellite, temperature sensors on the ground or whatever. And all of these things are going to have new information. Some of it's going to be redundant, some of it's going to be independent. And we want to find relationships between these things. So this can help us do things like reduce error bars, right? If there's mutual information, but it might also tell us something about phenomena and processes. So how these things are related might eventually let us go towards understanding causality. And so we talked a lot about hypothesis, this idea of like hypothesis discovery, like can relationships between different views of data actually hint at, underlying phenomena. And then we talked about the challenges basically with this complex data. And so we have multi-resolution. We talked about, minutes, years. I have things like picoseconds in material science. And so there's a lot of independent information in these views. And one thing that was of common interest for us was the idea of creating like a unified, like latent representation from multiple views. Right, so then we talked a lot about the processes that we need to analyze these data, methods that could be either agnostic to the domains or how much you need the inductive bias, right? So as Vandana mentioned, sort of halfway in between like ML challenges and inductive bias. And then also, there's domain specific constraints. So in material science, we can turn a lot of knobs, change the temperature, whatever. In the iHarp program, they can't turn down the temperature. That would be great. And so, yeah, we think there needs to be some kind of common discussion around the idea of like transfer learning in this multi-fidelity, multi-view space. So did you?
And one of the things that we both discussed from the material science to iHarp on the ground is a lot of these complex problems exist in any domain. Any of the institutes are dealing with these complex big questions that we want to answer. So while we are creating all of these new machine learning models, sometimes we might use simpler models, but really look at the data more carefully, look at the multi-view data. And that's going to try and help us answer the bigger questions, the grand challenge questions. And things like uncertainty, fidelity, all of those things come up in a complex environment. So it's a call to action to all institutes to think about your complex data And as a next step, I really like the timeline. We were nowhere there. We just had fun talking, which was really great. But the next step for us could be getting together as institutes and other grants, talking about your grant challenges or your bigger problems that you want to address, and even have use cases around specific scenarios where you're bringing in this multi-view learning for biodiversity, for spatiotemporal scenarios, and so on. So that's a call to action to everyone. Thank you.
Are you Jeremiah? Yes. So the next one will be on inductive bias and learning. Jeremiah Sullivan.
Thank you. Good afternoon, everybody. My name is Jeremiah, for those of you who I haven't met yet. So I did a bad job and I did not include the names of the folks who were discussing these things with me last night, so I apologize. But it was a ton of fun talking about inductive bias and how can we actively inject scientific knowledge into learning algorithms to speed up scientific discovery. Next slide, please. Okay, so we started from the very top and started asking what is scientific knowledge, and that went okay. That was more or less easy to define as the systematic understanding of phenomena that we can formulate in rules that translate and generalize to either different people because they understand them, or different scenarios and these rules that generalize to other settings. That was fine. The problem is that then we started talking about what constitutes a discovery, and that led to a very heated discussion. And there seemed to be sort of two main views on this. One tied more to the physical world, and another tied more to intellectual discoveries and more of abstractions and mathematics. So despite how much fun talking about this was, I don't think we have a unified consensus of what scientific discovery represents. What we could agree on, however, was that it was discipline dependent. Nonetheless, it did not prevent us from moving forward. And so trying to sort of analyze how to inject scientific knowledge in machine learning, it's by now, we understand that some scientific knowledge is inevitable. We cannot learn anything. We do need biases. The question is, how do we go about implementing these and enforcing them? And you can also sort of look in time in how these things have been done. And so we discussed this sort of timeline of different implementations of these ideas. For instance, in sort of a version, 0.1 of how you could enforce biases in learning, you could consider a setting where, 100 years ago, 150 years ago, you knew or had a very good approximation of what physical laws were, let's say, approximately true, but you weren't unsure about a specific constant in these laws. And so you could regress data to find these constants. And this is a very explicit way of learning. We have a model with one parameter and we are learning this from data. You could also extend this to, obviously, to more parameters, still in linear models, or what you could do, let's say, after in the 21st century, is then build predictors that explicitly use these laws as input. Or you could turn the let's say these laws and these representations that are computed based on physical systems as features to learn whatever predictor you want. You can do more sophisticated things as well. You could formalize this in a Bayesian framework. You can try to formalize these things as priors and then including them in your learning algorithms. Sometimes you can actually explicitly introduce these structures in your models. So say that you know that your data has some models, a system with symmetries, you can build predictors that explicitly make use of these symmetries. So it's a very explicit way of enforcing these priors. So after discussing a lot about these different options, we kind of realized that there's no sort of unified way of let's say, of developing a framework to that would apply to many different settings and the many different learning scenarios, and they're very different scientific disciplines. And so we sort of started entertaining this idea of, could we, or could the scientific community come up with a overarching scheme on how to operationalize this? And so, and we started sort of pinning down the perhaps in hindsight obvious fact that you do need humans in the loop to define what scientific knowledge is. And then we entertain these notions of asking questions. So you could, for example, let a domain expert in conversations with a machine learning expert formalize 20 questions that the machine learning person should be able to ask to answer from data. And that is one way of sort of, you know, narrowing down your hypothesis space. And so whatever you're going to tell me as an answer will be given as a function of these binary answers to these questions. But then you could also do the same the other way around. You could actually ask the machine learning expert to formulate 20 questions about this problem that the domain expert will answer. These could be of the type, what kind of invariances do you expect in your problem? What kind of you know, what kind of physical properties should I look for? And those would in turn, inform the development of different learning algorithms or different hypothesis classes. And of course, you don't have to stop here. You can continue this conversation and perhaps, you know, sort of in a hierarchical way, refining your hypothesis space to make this more formal. This is by no means, you know, a formal idea yet. It's just sort of a curious intellectual exercise to think about this notion of formalizing, injecting domain knowledge in this game of questions and answers from the machine learning expert as well as from the domain expert. We don't have a timeline, but I would love to see this formalized in the next couple of years. So if you're interested in this, myself, and I'm sure that the rest of us who were there last night would be happy to talk more about it. Thank you.
Thanks. It would be good to think about next actions as far as maybe creating a small group, or, I mean, these you're thinking about all these things, but okay. So the next topic is on data and cyber infrastructure. So it's Anand and Jinwoo. There you go.
Thank you. Yeah, last night we were planning to have, I guess, 3 breakouts, but in the end we combined to a single breakout. And we mainly discussed the challenges associated with computational reproducibility. A bunch of challenges were mentioned, including like the data and the codes constantly changing, the difficulty between switching between HPC and the cloud environment, as well as kind of the high cost. I think Jeffrey mentioned here in terms of the high cost of keeping the national cyber infrastructure or the DOE and the NSF-led cyber infrastructure technologies slightly different or different from what's going on in industry. But however, there are challenges with industry also moving so fast and difficulty of keeping up with these kinds of things. And these all impact reproducibility in some ways, that like the codes that you developed like 3 to 6 months ago might not be, and you publish a paper and it's no longer, the versions are not matching, and containerizations were mentioned, but they are not kind of the solutions to all the problems, I guess they have. Next slide, please. In terms of potential kind of solutions, we also discussed journal referees and requiring codes and GitHub's repositories and things like that submitted. It will not, again, it will improve the reproducibility of the things out there. And also one of the ideas which was mentioned, I guess, multiple times was have a potential new journal where like its sole focus is on getting reproduced work published. So generally we think of publications as new concepts, new ideas that are published, and you don't have space for reproduced work. But generally, like if graduate students and others who are doing this kind of work, trying to reproduce things, if there is an incentive to get these reproduced, and there is an incentive for the authors also, right? So their papers get reproduced, and that's great. And then the students, whoever are reproducing it, they get a paper in this journal. So that was kind of an idea which was mentioned. And then education was also mentioned as an important component with reproducibility. We also discussed some of the future steps we could take, and we would talk about that as well.
Yeah, next slide. So based on discussion we had, so we move on to what actually can be done by this community. So but firstly about reproducibility. We know EarthCube as funding the program, they host a peer-reviewed journal notebook. I think that's a good moment in the community. They think first the reproducibility, it just not can be say I'm the author and I think it's reproducible, and you give me credit. We have like a paper need to be peer-reviewed. Other people be able to evaluate it. So we are thinking this is a good moment. Maybe we can follow it. We have a next PI meeting planned for the next year. Maybe we can do the similar thing for this HDR PI meeting. So each attendee, they can submit their work, and we have a separate committee that's doing evaluation of the reproducibility. And if they can do it, and you will be put in a bunch of presentations that's actually evaluated by a third party. I think that's something we can do. And also moving from a traditional EarthCube and others, we in this HDR, we talking about the big data, we are talking about HPC systems. So moving a little bit more forward, we are thinking about whether we can do it with distributed environments, either the cloud HPC environments. Can we have starting with examples, thinking all the way to the end, it's difficult, but we can start with examples. What is a good example to do reproducible research in your particular discipline and in a complex system? The second part we discussed, because we have the Jeffrey Fox invited to this talk to give this very interesting comments for science. We think they already have very dedicated design and bi-weekly meetings. We think it's difficult to reinvent everything and do only within this community. If we can combine our efforts with their efforts, we can join their efforts to propose a little bit different new use cases. For example, we have many DSC and to institute working on geospatial data. Maybe we can spatial temporal learning and geospatial. Can we find a use case for it? And the whole working group combined with Common for Science to look at together. We're talking about the foundation model, where you even it's different use cases in a particular project, but foundational level, there should be some kind of model can be learned across, can utilize temporal and spatial information. The second one, I think we talk a lot in the 2 days about knowledge guided machine learning. Can we have come up some foundational model that can study ways to embed the domain knowledge into machine learning? That's the most thing discussed. Thanks.
Okay. And the last but certainly not least is Valerie Barr from to talk about education working group.
Okay, so there's a lot of ground to cover. It's going to go quickly. Don't try to take notes. We can get all the notes put into the agenda somehow later. So we didn't have questions. We had 2 topics. Also, we met in the bar. Don't worry, NSF folks, everybody paid for their own drinks. And that got a lot more people coming than we expected. And I don't have all the names. So number 1, so these are all the things that came up based on our first topic. And I'm just going to expand on each of these a little bit. So the first question was like, do we even have to have a separate data science degree? And if we do, how is it different than computational science in a CS department or applied statistics in a statistics department? And how do we make sure that students actually get domain area knowledge, and how much domain area knowledge do they have to have? Moving on to point 2, where should an intro data science course live, and where should a data science program live? Should intro data science be taught in a data science department, a data science program, or should every department grow their own intro data science course? And depending which way you go, what will the students be missing? but yet data science is inherently interdisciplinary. So something's got to happen to unite it to the domain, unite it with the domain areas. And then this also raises an issue, which a number of people were bringing up this morning, which is how does data science fit into the institutional budget model, depending on your institution? And that raises a question of how does the institution see data science? Is it a handy thing to have because the institution has people that have a lot of data? And wouldn't it be great to have people in-house who have the skills and knowledge to help people deal with that data? Or is it really a legitimate academic area that you want, in which you want to train students? Okay, so then the essence of the data science program and the content of the data science program are related. Definitely interdisciplinarity is key. But in terms of content, do you grow your own? Do you pull from the Berkeley Data 8? There are starting to be models out there. We talk about reproducibility. Let's talk about adoption. Why are we all growing our own programs? There's a question of where students go, given the market these days. It seems that the majority of data science students are going into industry, which leads to the next point, which is the incredible hiring crisis that we're facing in computer science and data science and probably statistics. Very few applicants if you're at a small residential liberal arts college. So those schools are at a huge disadvantage. And increasingly, we need to be able to hire people who are coming from domain areas, hire them into computer science and data science programs, but then they have to be tenurable in those programs. So there's a boatload of challenges in terms of building out, having enough faculty to build out these programs. And this kind of exposes the tension between the glacial rate of change in academia and the incredibly fast rate of change in the data science, AI, machine learning world. I have a lot of opinions on that, which I will not share at this moment. And then we talked about the real need for resources, starting with a portal of curated data sets that cover lots of domains. So faculty, again, have materials. They can, if they can get course content that they can adapt and adjust to their situation, materials that could be used in foundation courses, professional development for faculty so they can learn how to teach data science, and then using the DSC projects as models for workforce training that they can incorporate into their institutions. Okay, next slide. Okay, by then, maybe we were straying a little. And so we spent less time on this second topic. But again, what came up was the need for resources that would support data science education, right? That portal of curated data sets that would also get students thinking about that idea of reproducible data science activities, data science work. The question of how should domain experts be prepared? We talk a lot about training students, but there are a lot of people coming into data science from various domains. There was discussion about that this morning as well. The carpentries, how are we going to get these domain experts to learn GitHub and Linux and command line and all of those things that they need to be able to do without saying to them, haha, you have to go do an undergraduate data science degree. And then two quick suggestions, which I'm just going to make. They weren't part of the discussion yesterday. One is a lot of you have REUs. The data science groups have students. Many of you have REUs. There's no simple way in the NSF Search REUs site to find those. So it would be great if we could somehow, either if NSF could generate a list or we can crowdsource here, generate a list of the REUs that exist within the HDR collection of projects. So the data science, the DSC folks can send those out to our students and get them applying for your REUs. And the second suggestion, which I've already made to the folks organizing next year's PI meeting, is that there be a chunk of time where the DSC projects can all get together. We need to begin to distill out what were our successes, what were the challenges, and what is the roadmap that we could give to other institutions so they can build up an experiential learning, data science oriented workforce development program on their campus without needing $1 million from NSF. Full stop.
Thank you. Okay, while we transition, can you bring up the original QR code slides? While yeah, I can go one more. Oh, okay. I put the photo in the slides. I thought maybe you could, can you reload? Just reload it, I think. No, not in this slide deck. The original one with the QR code. Oh, it's a Google slide. It's whatever's linked on the Indigo page. It says G slide on our session. Anyway, if you could bring. Go to our Indigo page. Yeah, the Indigo page itself. And then go to our session and reload it or whatever. In our session, there's a G slides. You go to our yeah, that one. Oh, okay. Well, it's not in there. I know I put it in there. It's in a slide. Okay, whatever. Okay, so what I was just going to show you the picture we took and just make the point that that group that you'll see the picture, it's also somehow loaded. Yeah, G slide at the top, whatever that is. There's so many Google slides flying around. That is bizarre. It's literally on my computer. I mean, I have evidence. It's that Google slide. Anyway, there's a picture that we took. And so you can see, and my point, I just wanted to have it up to make the point that, yeah, I think in terms of, we heard through all the talks that there's real like unifying common threads, for example, in education. We could do things within the HDR institutes and the HDR ecosystem that would really make an impact in the education space. And we know we have a real workforce challenge in the US now and looming. So and similarly on cyber infrastructure and some other things. So I think this is the group, and I was going to point to this, the picture of us. But this is really the group in terms of harnessing and harvesting the data revolution that over the next few years, we are the group, I think, the leadership and all our postdocs and students and that work in our efforts to really drive forward some key elements like cyber infrastructure, the education space, and all the other ones were mentioned. And all those things that you heard are really unifying in terms of like data challenges. Wouldn't it be great if we had data challenges, that ML challenges around data that could be impactful in multiple domains within our institute and things like that. So I think these are the kind of things when we look at what's going to happen in the next year's meeting. Between now and then, I would really like to see a set of working, informal working groups being created and meeting and planning and being active before the next meeting. Okay, so I think what we wanted to do was to have an opportunity now to just come back to any of the slides you saw, interject any other new ideas or things you want to discuss, and please put them in the Google Doc. But I think this is sort of the open mic part of just getting feedback on anything you heard here or new items. I don't know how long we have for this session, but probably negative time. But anybody who has hey, there we go. I don't know how you found it, but this is proof that I put it in there. Some Google slide. Anyway, this is the group. This is the leadership team, plus the people who are virtual, plus the people who couldn't come. Blah blah. But and then all the so this group of leaders, I think, are the ones that are going to really drive this forward next few years in terms of data-centric research and in science and engineering. So yeah, that's what I was going to point to earlier. Does anybody want to have? So let's just open up to discussion. Anything? You can pull back up the slides on the working groups if you need to refer to them. But other than that, are there questions or points that people want to elaborate on in the kind of activities we should do going forward?
Just while people are thinking, a quick note on the last talk. If those of you who do have REU sites, the simple way to get the data science to show up in that search is to bother your program officer, NSF program officer, in charge, overseeing that. and they have the ability, or somebody in their division has the ability to add keywords to that listing. So it can be done. It's actually not that difficult, but the person, whoever's in charge of that, of the REU sites for that division, has to be asked nicely to add that keyword. So it can be done. Just take as a small action item.
So I have a question for the data science core people who are here. Do you really want to wait till the next PI meeting for this meeting? Why don't you all get together on your group and let me know?
That smells of an opportunity.
That's what's known as an
Any-
invitation, folks. About as clear as I can make it.
Any DSC? Or a flaw?
I threw it out there, but
Okay, folks, let me explain how it's done at NSF. Somebody writes, somebody gets together and some lucky person is it. And it writes, he, she writes the proposal and sends it to me. Okay, come on. It's not like you're new to this. You've done it before at least once. Nobody's a virgin here.
Yeah, we're existence proof of you've done this sort of thing before. So.
Yeah.
Thank you. It could just be, I wish we had those at CERN. We actually have these like squishy balls that you can throw around that have embedded mics. I wish we had those things. Anyway, anybody want to go, Tanya?
On the subject of sort of sharing infrastructure resources and so on. So a quick one for DSCs. I'm seeing, I saw a lot of the, we're generating data science modules for, this domain or that domain, but there's a lot of similarity across. So for those of us who are not DSCs, for example, we would love to not have to reinvent the wheel when we're, adding data science, machine learning modules to domain scientist training. Whether it's an undergraduate, we're actually going as sort of from the beginning of middle school. We're trying to push even beyond, but like middle school, high school, undergraduate, and so on. So how do we federate these resources and make them available throughout the HDR ecosystem? Pardon my ecology colleagues. And Peter's not here, right? All right. So and make them available to the broader HDR community, educational community. Similarly, as we're talking about, data sets and challenges. So now the flip side of it, the research and data. So yes, I found that a Dear Colleague letter for data reproducibility and replicability that came out 2 days ago. So this was October 25th. And I have lots of questions for Sylvia for that one. But, for one mechanism of kind of making sure that we make data sets and methods available also as things come out, well, there's model commons. We may really have a good conversation of how to make it for the broader HDR community beyond come show up at our workshop because that's a very kind of non-scalable approach. How do we make it a little bit more scalable? Perhaps we are using model commons, by the way. And maybe this is a conversation about mid-scale infrastructure proposal of connecting some of the existing data resources into a research-ready data infrastructure, at least for some subdomains where it doesn't exist now. So come talk to me about the mid-scale at least, but otherwise
Yeah, I just want to touch on the vision. The vision we talked about in the education working group last night over the drinks you saw is really that we want to have just the data we want to encourage. And there's a number of existing funded programs around FAIR. So we want to make sure the data sets are fair. And efforts within this ecosystem have data sets of interest, which we use for educational purposes or training. Are encouraged to make them adhere to the fair or care principles and put them on some digital repository with the DOI and everything. Zenodo is one of them we use. Then also on the software side, we wanted to have through GitHub organization with repositories, we wanted to encourage the open source development of Jupyter notebook based appropriate call out also to R and all the other, but basically thinking Python ecosystem, essentially have an open source set of in the spirit of open source, people to be able to contribute modules for educational purposes that tie and use the data that I just described for education. And we wanted to try to standardize that a bit. There's tools from data science we use in the FAIR community called Cookie Cutter, which allow you to have templated formats for the kind of modules. I also say that the American Physical Society has a working group called DSE COP, which they have fellows that have developed in a standard format modules for data science education that are tied to data. So I think that is a bit of a model for the kind of thing we can do. But once we have this, so that an educator, not even in our community, could just pull a la carte and say, I want to do something from geospatial and particle physics and astronomy, and be able to have a portal to be able to pull that content in. The data is known where it is, and also the modules that have been written can be contributed to. And now I can make a course. I can evolve my course by having new content based on this. None of this kind of coordination exists. And this is an opportunity for this group to do something around the infrastructure, but also the approach here. The next, I saw him here.
So I want to follow up on that topic of federating resources and sharing things. And I'm wearing multiple hats. I'm also the NSF, one of the NSF's funded systems, ENVO. I'm the PI of that system. And so I don't know how much of this community is aware of the NSF funded access cyber infrastructure ecosystem. It used to be Exceed, now it's Access. They're always very good coming up with these very smart acronyms. And so the good thing about that is it's free. It has a lot of large systems, large storage, cloud. I know Jeffrey said, you don't want HPC, you want cloud. But HPC today is very different from HPC maybe 20 years ago. You don't have to do parallel programming to get on there. You can get on there through Jupyter notebooks. There are a lot of interactive access to it. And so I would really like to be part of the discussion when you talk about running these activities. And if I know some of you have access to clouds, commercial clouds, but this is free and you can get to very large scale to be able to run stuff that you cannot run on commercial clouds. And probably usually due to limitation of funds. And data transfers don't cost you anything. It's a great place if you collaborate with multiple institutions. I remember somebody talked about running something out of your own institution that people cannot get accounts and stuff like that. So if you're interested, I'll be happy to chat and contact me if you want.
Colab works pretty well, and you have GPU access and even TPU access, but the scale, it's not clear it works for all scales. So, Google Colab, it usually works for courses, but it's not clear it's efficient. Yeah, it's okay. So there are points to raise. Maybe on the data challenges, for example, because I think there is definitely some things we need to organize there. And it could be really a unifying activity within the ecosystem. And the best part of the challenges is not so much who wins and how it happens, is the learning that happens after when you compare your solutions and get together as a group. And I think that's a very exciting area. if I held it long enough. So.
Questions are good, right? So I have two questions. One is, okay, so now we all go back, and have to catch up on grading or whatever stuff, whatever. But so people have made contacts, but I'm wondering if there's a way, I mean, we have the list of all the participants, but how do we all stay in touch? I'm not necessarily suggesting a listserv, but maybe, there needs to be a place where, like, if the group that Tanya's talking about, we're going to get started, or the education, like, maybe there's some people here as stuff is percolating, and when they see there's a call, people are going to work on it. Like, it would be good to collectively know. And I don't have the answer on that, but maybe there's something that should be done for folks. The other thing is, I'm just curious, Exceed is gone and Access is new. And is anybody working with Access? I would love to know for our project. So who's working with Access? I need to talk to you. And anybody else? Yes, Phil? Okay, great. So thank you.
I think on the important point she was making about how do we communicate outside of this meeting? So did you? I thought I saw yours. Okay. I don't know if you wanted to comment. Yeah, it's an excellent question. I mean, we could have a Slack space, you could have a listserv, all the standard Google groups, whatever. But like, yeah, somehow we should have a low impedance way of communicating after.
Yeah, it's a topic we have been keep thinking about when we have the organization meeting. And one thing is that the three major research theme and activity topic we organize here are aligned to the HDR goal and mission. Each of the area have slightly different preference of the approach, how to organize the event, and also the priority and readiness and timeline also slightly different. For example, in the machine learning challenge, there's a clear timeline project out, and for there and Phil is volunteering to work on the coordination, and there will be a general call to all the HDR community, whoever would like to participate in the MLO in terms of providing resource or idea of resource and the idea of a challenge. So this event will come up. Then for the other areas, and we know there are interests of partnership and collaboration, and we want to have a platform for people to talk. I think for today, you'll be a good starting point, and hopefully you have found 10 new friends in this meeting, and you want to continue the conversation. And we would like to welcome everyone. If you think that two of you or three of you have some idea that you want to scale up to have a broader event going on, and even you are looking for some support, organize some event, it could be a smaller scale with a very focused subject to go on. And the supplement grant that we have generous funding from NSF could actually be think about reallocate to support such an event. So it could be a very convenient way that we can foster the cooperation within the community that we all meet here. So this is something we can do during the 1 year of the activity time toward the next PI meeting. Of course, if we think about just one final comment, and there are many platforms for people to communicate. There could be a Discord, there could be a Slack channel, and we thought about whether we should have a centralized platform for everyone to for information. But for that kind of discussion, there's no consensus of agreement during the organization meeting. Maybe this is a good time, and if you have some idea you think there'll be benefit to approach this way, or you have a candidate platform you want to propose everyone to use, it's great to share that with everyone.
Great, thanks. Mine's more specific. yeah, the DSC is probably a good idea. So if DSC wants to get together, did I say that in the right order this time? DSC, yeah, DSC. If you want to get together, come to table 6 and let's just put emails all in one place so that way we can do something about maybe doing more collaboration. That was it.
Yeah, I'll throw out a very quick challenge here. With suggestions of one of my colleagues, so it looks like HDR.org is already taken, but NSF HDR.org is not. So if anybody wants to, charge to their grant the creation of a new website, you're up for it.
Can someone take a note on the Google
I
Doc?
see somebody already trying to grab that
Okay,
and sell it to us later, but.
Oh, hold on, microphone.
No, Google has this workspace, which kind of enables having a team and sub-teams, and it kind of integrates with the Colab and with the Google Drive, and so to share documents, and it's kind of a common platform. So it's workspace.google.com, probably a place for us to have a larger group and subgroups within, and have interactions within the subgroup, and if necessary, expand beyond that subgroup to pull other groups in. So the platform kind of exists. We can use it to our advantage if we want to.
Great, thank you. A quick interlude. Should you? I just want to make sure the other activities of this, I mean, how are we on? We could keep free-forming this. How are we on time and activities? I see some pointing at watches and things. Are we good? Okay, so yeah, other comments want to bring up? My little comment was not meant to thwart discussion. So we apparently have a lot of time. So, okay. Yeah, good.
So this is actually, this came from a suggestion from, I've forgotten your name, over there. So, and Shuche actually. So, but basically a lot of us, and this is kind of tacitly mentioned in a lot of things. I think we could make it more clear. There are a lot of DSCs here who have internships or looking for, summer research. And there are a lot of institutes here who could very easily make summer research projects for students. I can think of my own group. We could definitely use like some summer students. There is a scheme, there's no scheme to formalize this, but this is again, kind of related to some of the other efforts, putting REUs in one website. We can have a REU, institute to DSC transition. And I think this is very kind of an easy step for us, especially since we're all mostly speaking the same language, right? Either Python or R. So I think it would be pretty straightforward. So it's something we can follow up after the meeting.
Okay.
Closing. Okay.
Great. And let's thanks Mark and all the lead of the breakout session. Thank you for your effort. All right. We will move to the final session. I know many of you are thinking about, oh, my flight is coming up. So before we move on, I want to just let everyone know that if you have an interest, want to find the carpool together, and just after this session, feel free to come forward here. I think it's easier. We can match out people, and maybe some go to Union Station, some go to the airport. We try to organize an event. Initially, is thinking about to just let everyone know each other, know everyone work. But we put one step further. We are looking for, after this event, we are going to have some follow-up activities towards the next PI meeting. Therefore, we structure some of the event. We have a poster session. They have a chance to share your work with everyone. I apologize, like we a little bit underestimated the possible heated discussion during our panel and also invited the speaker talk. But you agree that's a nice discussion, right? Great, yeah. It's all contributed by all of us. We have the slide up and we have the recording of each of the presentation up. So we would like to encourage you, when you go back, advertise this event, advertise those contribution to your colleague. And we are all in the same community. And we are represented here. We want to bring message back. We are going to have a joint effort coming up. We want to make a bigger event in the coming years. So in this open mic session, we do reserve some time. We could talk about some ideas that haven't covered in the breakout session. And thank you for contribution. We have 2 contributions and we'd like to bring up a slide and then welcome you to come up to share with us your idea. Could you help to step the slide? Thank you. And we start from Jing.
Hi, everyone. I am Jing Gao from University of Delaware. I should preface this with saying that this is my first time being at the HDR PI's meeting. So this seemed like a new idea to me, but I'm sure many of you have thought about this for much longer and deeper. And really from the earlier sessions, it sounds like there's really a lot of overlap. But Shi asked me to put this slide together because it was from a self-organized discussion involving a few of us from the poster session yesterday. It was before the breakout actually. So we were thinking about the same things, is how do we connect? So there's no question that we want to connect, but how do we do this in a meaningful and not so burdensome way? This may be generalizable, but just for Shi and me, one institute and one data science core, we felt like our students need internship, and we have some partners, but we can also send them to the institutes. And we thought about how to fund this with our DSC. We had some student participation funding, and the institute might be able to contribute some as well to share this. And at our universities, undergraduate student participation support falls into same category as tuition. So it's education costs and maybe free of F&A. Maybe you already know this, if so, sorry. So we thought between the institutes and the DSC, we can pass graduate interns and maybe they become graduate candidates. And then we thought we can be more ambitious about this. And among the DSI, we all develop education modules, but with different emphasis, but many of the topics are shared. So for example, one thing we hear a lot is data ethics, and we plan to do that with our DSC as well, but we'll only be able to do that for maybe a 3 seminar series, but we know we have a DSC is all about that. So we were thinking maybe, when you guys develop your course, if it's education module or open course, we have, again, common directory or portal, but not just for data set, but actually just for course materials. It's as if we taught a course for a few years, we're going to pass it on to another colleague, you just dump there. We don't need to talk with each other unless I need to teach that course. I just go to, say, this shared Google Drive and look up, hey, someone else already developed it, and just borrow the material. So we thought among the DSIs, DSCs, we can share that. And then we thought, okay, we can go even a bit more ambitious. Well, how about we include the tripods as well? And we know you develop, maybe many of you develop new methods, and you're already gonna create workshops to present that to your audiences or your own communities anyway. Just also put that in a depository, because we also have boot camps for coding and statistics, so we can use your materials. And then maybe if you also need student participants, and we can pass that to you. And then we thought, why don't we connect the last arm? Then we're a beautiful triangle. No, obviously we see a lot of research questions and the methods both the tripods and institutes develop, and you can pass onto each other and cross-fertilize. But because I'm based in the DSC, I will stop speaking out of my depths there. So again, what connects all of this together in a meaningful but not so burdensome way? I think, we already donated a day and a half here with our bait fish saying you're not moving enough. But then once we go back, how do we maintain connected? And just one very basic idea. Again, next, thanks, is this minimum effort shared repository. And really could be, we can get some open repository portal, but it could be as simple as just a shared Google Drive to start with. Everyone already use it, and it's so simple. So just that very basic idea from a newbie. Hope to hear your more polished ideas.
Just thank you, Slava, for the very, very wonderful suggestion. So nsfhdr.org is now bot registered, so we can use it for disseminating this information, whichever. And so, to create this more explicit community, it can be linked to Google Sites if we want directly, but the domain, we can, including redirect or whatever we want. But so now it's now ours.
Great. And there are the comments, or you want to sign up during this triangle effort, and feel free to follow up with Jean. Is it okay I volunteer you for making a
I
connection?
just heard that for the first time, but sure.
Yeah, this is really great, and it's very consistent with what we talked about before. Like,
Yeah.
so it's I would. So should we have a little working group that you lead? How is this? How do we execute your vision?
Yeah. May I suggest that we send out a Google form or something for people to sign up to different activities within this, and that would automatically form kind of ad hoc committees that would work on different areas, and then we'll bring it all together during our next meeting.
Agreed. Yeah. I think that's the way to define a set of groups and let people sign up, and then we'll figure out how to meet.
Okay, great. Oh, so Vandana.
I can run it.
You should. No, you stay here.
Okay. Last comment. I feel like there's stuff that can be simplified a lot more. There was this whole effort around ethics. I forget, the name escaped me, but someone from Colorado created an Excel spreadsheet with all ethics courses, and it just became this snowstorm, a big snowball. So I think your idea is really great, Jingtao. I think just connecting through simple documents. I love the idea of subcommittees, but even simpler stuff like that, it could snowball very quickly if you just have some links, information just thrown into a document together. So subcommittees, but even simpler stuff will get it.
Yeah. Simple things, easier to do.
Oh, hold on.
I think in the GitHub community, I think people use awesome list. We can create an awesome list for the courses. I think people can go there, submit as one as a submission, and another person will verify it and then put it there. I think overall, I think at least in GitHub, if you have awesome list, people tend to use it much more than just because Google link is just too complicated.
I strongly suggest that since you own the domain name now, thank you, Tim. Thank you, that you use it and you brand your activities.
Good. All right, let's thank Jim again. Then we have the next proposal from Eric.
All right, I've been up here too much, so sorry you have to see me again. But so I have the lucky task of organizing the next one of these It will be in the great state of Colorado. Here's a rather abusive view of Colorado from above. We'll be at the little smiley face. This will be about, my guess is that we will have support for on the order of 80 people for full travel. But if we include like the Front Range and perhaps travel funds from the institutes and things like that, my guess is by the time the dust settles, it'll be more like about 120 person meeting. So put your meeting people pants on for that. My guess in terms of where we will lean is that if we think about the triangle that we literally just saw, I think I labeled it slightly differently, but you can kind of think about, student development, foundational methods, and sort of domain applications. My guess is that we will tilt compared to this meeting more towards domain applications. So bring techniques you want to solve, bring ideas in that space. We also have actually a fair bit of funds over the next 4 years to run small workshops that are on the order of 40 people workshops that are, again, all expense paid trips, mostly to Colorado, but also to places like Princeton and other parts of the ID4 Institute sort of, university set. So for example, it looks like this August, we're gonna really do it like an applied machine learning one focused on the physical sciences and engineering. And then in May, I believe Jane, are you still around? You are still around. There you are. Shoot, you were just talking. Why do I even ask? Yeah, Jane, do you want to say like 2 words about yours? Or 10 words?
Yeah, we're looking in May. Drexel's on the quarter system, so some of you would probably already be done classes, but we will still be in the midst of things. We don't end until June, but we're looking in late May to do some kind of workshop across, people from across this ecosystem, and then some other communities, of course, that would come and address AI ready data, AI readiness, but looking at specifically knowledge structures, things like metadata, fair ontologies, and also looking at their role across disciplines in the creation of knowledge graphs. So knowledge discovery. We often talk about data, but there's a lot of unstructured data out there that needs to be harnessed as well. And these tools are really important for helping us complete data sets. I mean, Paul and I were just talking about this in terms of adding to the Phenoscape ontology. So what can we do in this area? So please reach out to me. I mean, I'll work with Tanya's new setup infrastructure to communicate about it. And Tanya, I just have to say, I think I have a good homepage photo for you, which is our group photo, but that's another story. Anyhow, I took some extra liberty, but thanks, Eric.
Thanks, Jane. Yeah, so in short, we are going to be needing to form organizing committees for all of these workshops very soon. Time flies when you're having fun. And we would very much welcome, your volunteering or your suggestions for who should be part of these organizing committees. So with that, I think I'm good.
Great, thank you, Eric. Any question for Eric? Yes.
Yes, no, I was just going to say, it's not a question for you in particular, but since we're doing meeting outlays and now we have the Tanya infrastructure, which I've now deemed, or you did, and I've affirmed, there's also going to be is it 2024? There's planned for a few hundred person meeting with the HDR ecosystem, but beyond in terms of bringing in AI institutes and others, a few hundred people in Urbana-Champaign. I think this is 2024-ish, late 20, I can't remember the timeline. But
you decide.
Okay. Oh, I decide. Okay. So later the better. No, so yeah, I would also be looking for help, but this is at least 2 years out. But I think when we get as we get this up, we should start to make, a plan of outlaying some of the meetings we want to have. Most importantly and impactful is the ones that are going to be the smallish ones, the working style ones that we hopefully will pop out of the vacuum based on this meeting.
Okay. Thank you, Eric. Okay, Sylvia, you have some announcement?
I don't have an announcement. I have a thank you. I have a thank you to all of you. That includes the hardworking people of the organizing committee, and then sometimes not so hardworking members that couldn't make all the meetings like the NSF members. I want to thank the UW people who collectively made a small miracle here and reassured all the program officers, I think, that our vision for what was actually going to happen in HDR could happen in HDR because of the people, you all. I know it's a lot of work. I know it's exciting, but I know it's also exhausting. So I really look forward to the next several years of outcomes. I wish you all safe travel since you actually did travels. I guess that used to be part of my talk all the time, right? You know, let me know if something happens to you on the way home, ... And I got out of the habit of ever saying it, but I do wish you all safe travels. And I really want to thank my NSF colleagues. You all have not seen the 5 years of work that went into making the program, the talking about the program, the meeting about the program, the talking some more about the program, the writing solicitations, the running the panels, the . But my NSF colleagues have been spectacular on this. And if you actually achieve what we hope you will achieve in education and new insights in science, it will because they broke their backs, giving you the chance. Anyway, thanks everybody.
Oh, yeah. So I would like to express my personal thank you for all the organizing committee. Could you stand up and let everyone give you applause about all your hard effort? Thank you. And we have a really excellent audio support. And let's thank Charles. Right, so finally, let's thank for ourselves. We really, everyone deserve all this. Okay, and wish everyone safe home, and we bring more homework back, and that's really what we want, right? Okay, let's go.